Yeah, good afternoon, everyone. Nana. Yeah, good afternoon. Previously, we completed few models. I think yesterday you wrote the exam also. How you felt from friction? How you felt the friction yesterday in exam? Easy only. Okay, very good. Then it's okay. Felt opposed. What opposed, Mr. Amok? What is the meaning of that word? Felt opposed. Okay, then here nothing. Sad. Okay, okay, okay. Maybe I don't know. What are those two or three questions, Mr. Ishan? Right. Anyway, we come to continuation here. I think as previous one, what I said, like pushing and pulling, and then followed by any model I explained. That's all I think. Yeah. Okay. Then next, come to this model. I don't know whether you saw this model in the yesterday's exam or not. Look at this model. Actually, this is a table, and mm, what is that homework problem? And here I placed one chain like this, hanging from the edge, like here. Okay, this is the chain. And the surface is suppose rough if I take. Why? Because this is friction chapter. What I'm saying, uh, okay, total mass of chain, I'm taking it as M, and total length is equals to N by L. Okay, in the given figure, good afternoon, Anna. In the given figure, okay, no problem. What he said, 1 by nth part of chain is hanging from the edge. Okay, if the chain is in equilibrium, I did not remember that question, Anna. That's why I did not give any answer for that. Okay, if the chain is in equilibrium, then mu between the table and I don't know, Nana. Mu between the table and the chain is, again I have to see back. Why? Because I did not remember what I gave in the previous class. The last one, what you are asking. Again, I have to open and see those screenshots. I think this is on third. What you asked, third? No, I think second. Second here, the last one, all of you asking. What is this last question? What I asked there. Yeah, that one now. Okay. A block is placed against the wall and applied some force perpendicular to the wall 20 newtons, parallel to the wall 4 newtons. Mu 0.6, m 0.4, then find the frictional force. Okay, that one only all of you asking? Yes, that I will explain later. Okay, then come to here, this question. In this question, first of all, what you have to learn, in the total length, this part of length is 1 by n, nth part. Like 1 by 2 half, 1 by 3 like 1/3, 1 by 4 quarter, 1 by 5th, 1 by 6th, like 1 by nth part is hanged. Then 1 by nth part mass here, there, placed vertically, and I think weight of this 1 by nth part will try to pull the chain to fall down. Am I right? Why? Because rest of the part is on the table. If this part of weight means mass of this part is not total mass. In the total mass, this is 1 by nth part. So weight of this one, shall I write it as 1 by 8th of total weight? Is it correct? This is mg acting here. Weight of this hanging part. Is this step correct, Nana? Those who followed this question. Yes. Okay. Very good. Very good. Weight of 1 by nth part is pulling the chain downwards means immediately to oppose that motion. Where is the friction existing between the table and chain? Here, the friction will oppose the motion and act like this. This is the friction. And he said clearly, if the chain is in equilibrium, equilibrium means about to slide. At that time, the static friction is called as limiting friction, static friction. This is mu ms, fms. Okay. And here in equilibrium, the applied force F dash should be equals to Fms, where applied force is that small mg trying to pull it down is equals to Fms. This small mg already I calculated here. This is 1 by nth of total weight mg is equals to Fms. We can write it as mu s into n. Okay. That n, yeah, I'm leaving to you. Anybody try to answer this? What is the normal reaction here? Normal reaction acts on the total part of the chain or the part hanging or the part on the table. Very good. Amol is correct. What about others? The part on the table. Correct. Good, Gayatri. Part on the table means the mass of this one, that is weight of that chain part, is the remaining mass. Remaining mass means m minus small m into g. Weight, because this weight is mg. So remaining is m minus m into g. Yeah. And that is equal to the normal reaction here on the table. Okay. So taking the normal reaction here. This is the normal reaction. So n is equals to, I have to write m minus m into g. That's it. If you understand this step, Nana, then the solution will be very easy. So straight away write it as 1 by n into mg is equals to mu s into m minus small m is again 1 by n into capital M into g. Okay, small m is 1 by nth of capital M. So here if I take m out, m get cancelled and g also get cancelled. Okay. Then here if you check, you will get on the other side. That implies I will get what 1 by n into m, both sides get cancelled, is equals to, I got mu s into 1 minus 1 by n. So if I take LCM here, 1 by n is equals to mu s into n minus 1 by n. So n cancel. I got mu s is equals to 1 by n minus 1. This is the shortcut formula to find out the coefficient of friction. If you have any doubt in my explanation, you can raise your doubt. Yeah. Do you have any doubt? Understood. Very good. Then, related to this formula, I am asking one question. Just checking for checking. Good. Right. In the above example, first question is mu, 1 by third of chain is hanging. Then mu s is equals to how much? Second one, if mu s is equals to 0.5, find the part of chain hanging from the edge. What will be the answer for the first question? If you understood that. Very good, very good. 0.5 is for the first question. Okay, right. And for the second question, Gayatri. Yeah, okay, Deepal, correct. Okay, Yashashwani. Oh, right, good, good. Both are correct. Right. So in place of n, how much you all of you substituted? Very good. Not 1 by 3. Is it 3 or 1 by 3? Ah, right. Good, good, good. That is 3 1. Very good. Then I think you understood the problem and you know how to solve it. Right. Good. Right. Accepted. So all are correct. N is equals to 3, not 1 by 3. That implies mu s is equals to 1 by n minus 1. That is 3 minus 1 is 2 half. That is equals to 0.5. Correct. And the second problem, he said mu s is equals to 0.5. So reverse only he is asking. 0.5 is equals to 1 by n minus 1 means reverse. You will get finally n is equals to 3. Same converse he is asking. Okay, good, right. So I don't have any doubt on you. You understood this model. And coming to next model here. Coming to the inclined plane concept, Nana. He said, this is the inclined plane of angle of inclination theta. Okay. And he said that here, suppose if I give the names like a top as B and bottom as B, top as A, bottom as B, and length of inclined plane, I take it as L. And the height of the inclined plane, I take it as H. Height. Wait. Array? Right, okay. I take it as H. Height of the inclined plane. Okay. What he said, if AB is smooth, the time taken by a block left freely at A to reach B is T1. Okay. That if the surface, if AB is rough, is T2. Okay. Given that T2 is equals to NT1, then N is equals to, okay, this is the question. So here we have to find out what, if a block is left freely at A, what is the time taken to reach B on smooth? What is the time taken to reach B on rough? On rough and smooth, we have to calculate. Okay. Long back in the same friction chapter, I think I said to you all, I don't know whether you remembered and how many remembered here. Time taken to reach the bottom of smooth inclined plane T1 is equals to root of 2h by g sine theta. Anyone remembered, Nana? Sorry, 2L by g sine theta, where L is the length of inclined plane. Yeah, very good. Ishan remembered. Nice. On rough also I said long back. What is the time taken to reach the bottom? Very good, Amok. Very good, very good. And T2 on the rough, I told root of 2L by G bracket of sine theta minus mu k cos theta. Yes, these two are already I told long back. Am I right? I told them or not, Nana? First you confirm. I told these two equations. Ah, yes, yes, correct. So I'm right. Yeah. These two equations, he said that T2 is equals to NT1 at. Then N is equals to how much he is asking. That's it. Okay, take these two equations, square and solve that equation. Okay, previously we got mu equation, Nana. I think you got 1 minus 1 by n square something you got previously, if I'm not wrong. Mu is equals to. Am I right? Yeah. Tan theta. Mu is tan. Okay, right, no problem. Okay, into tan theta. Right. You are right. Into tan theta. That is correct. Okay. Same problem. Here today he is asking instead of mu, n equals to how much? That's it. If you did not remember, solve it. That's it. If you did not remember that shortcut formula, then square on both sides. T2 square is equals to n square into T1 square. Substitute. By squaring this one, square would get cancelled. 2L by G into sine theta minus mu cos theta. Whereas that is by squaring 2L by G sine theta into n square. So 2L, G cancels, cross multiplication, sine theta is equals to n square sine theta minus mu n square cos theta. Oh, he is asking n only. Sorry. I should not expand. Why? Because I need n. So n square is equals to, I will get sine theta by sine theta minus mu cos theta. That's it. Therefore, n is equals to here root of sine theta by sine theta minus mu cos theta. Am I right, Nana, this one? Or any mistake in my explanation? Any corrections are required? No corrections. Right, good. This is the final answer. Okay, same question he asked differently here. And you got previously mu is equals to tan theta into 1 minus n, n square minus 1 by n square plus 1. Remember that one, Nana? Another answer. I think this as homework for you all. What I remembered, if I'm not wrong. Yes, correct. This is, yeah, on rough. What is the time taken to slide down? On rough, what is the time taken to slide up? The relation here is like T2 is equals to n times to T1. Then mu is equals to how much on the rough inclined plane. Yeah, that's what I'm saying. One from top to bottom, another from bottom to top. But both the times the surface is rough. Okay. Right. Those two models, I think, completed. All of you remembered. So happy. No need to discuss them. Okay. And here, one, a very important and complicated model is coming to the concept. What happened to it? Yeah. Coming to here. This is block over the block. Okay. One block is placed on the another block. What will be the motion? This is very important subtopic. Okay. Here in IP also textbook, you can find few questions, few numericals. And in object, obviously, it is very important. Okay. Coming to here, how they ask the question, sir? They say in basic level, the surface is smooth. Okay. And one block is placed on the surface, on the smooth surface. Then block over block, another block is placed on it, like this. Okay. Take their masses like capital M, lower block, and small m, the upper block. Yes. Right? And I consider this surface means the surface in contact between M and M, it is rough. Okay. In this case, model 1, I am asking. First model, what he is doing? A force of F is applied on the block small m. Okay. In that case 1, when you apply the force on small m. So again, once again, I am drawing the diagram here. Again, this is capital M, and it is small m placed over it, and he applied the force on this pink color small m, means top block simply. This is the force F, and it is rough as usual, and this is smooth. Okay. If you observe here, Nana, this block means small m, what I'm saying. When force is applied, actually that block should move. Okay. But when it tries to slide over capital M, because of the roughness between the surfaces, immediately what happens, all of you know, friction acts on small m. Same friction will act on capital M like this. I think no need to explain. Do you want any explanation here, Nana, in the free body diagram? Drawing the friction in the on the two blocks. No, I think all of you know it. Okay, good. Contact force. Yeah. So small m friction suppose acts leftwards on capital M. Another contact surface, friction will act in opposite direction. This is the friction. Yeah, contact force. Okay. Here problem is this friction opposes the capital F, so tries to stop to slide the small m over capital M. Okay. But on the capital M in the free body diagram, if you see the same friction trying to pull it forward. So if you see here, what I'm saying, the lower block tries to move forward because of friction. If it moves forward, immediately the block placed above the surface also moves forward along with it. Suppose I am in the bus, yeah, like carpet, like, or else simple example, I am in the bus moves, I am also move along with the bus. Okay, I sit in Kukatpalli, bus comes to here Hafsiguda, then I also here comes from Kukatpalli to Hafsiguda. That is a common thing. Okay, then in this case, suppose if I ask both are moving whether commonly or not, what do you say first? means they are moving commonly. Okay, why? Because capital M is moving along with the small m is moving commonly. But keep in mind, m is not sliding over capital M separately. Okay. What is there, Nana? Friction, Lakshmi Gayatri. What is this? When force is applied on this with in the direction of capital F on small m, this is the direction of friction. For every action, there is an equal and opposite reaction. This is a contact force. Contact force is the property of both. Very first day I told in the friction. Very fundamental concept. Very fundamental concept. So that contact force we have to draw on both in opposite direction, like normal reaction. One block is closed on the other block. Normal reaction, yeah, we write like this. On the other one, we draw like this, normal reaction. Same way, contact force, we have to draw on both. Okay, in free body diagram. Separately, if you want to discuss both. Okay, not combinedly, separately. Then I have to take like this. Okay, free body diagram. So what I say, with respect to capital M, the block small m is at rest. Like with respect to the bus, I am at rest inside the bus. Okay. Bus is moving, that's why I am also moving. The block M is at rest. M is at rest with respect to capital M means, can I say F net on small m is equals to 0 with respect to capital M, Nana? Is it correct? Yes. That implies F net means in free body diagram, I am seeing two forces here, right and left. That implies F, another one is in opposite direction, minus F is equals to 0. That implies I have to write F is equals to F. Okay, is it correct? Yes. And with respect to ground, if I ask, yeah, with respect to ground, bus is moving, along with the bus, person is also moving with the same acceleration of the bus. That's why I say F net is equals to small m into A. Will you accept this one, Nana? With respect to ground. Yeah, good. This is with respect to ground. Why? Because with respect to ground, block is moving, capital M is moving, means along with the small m is also moving. Then in this case, with respect to ground, what I have to write? F net means again two forces are there. So F minus F is equals to MA. Okay. And same with respect to ground, F net is equals to capital MA. This is on lower block. And F net on the lower block, there is only one force on the lower block, that is friction. F is equals to capital MA. You understood the whole part, Nana, here with respect to ground on small m and on top capital M. And do you have any doubt here? Yes. Do you have any doubt? Understood. Okay, no problem. Then good. From the two equations, once you observe, okay, thank you. Once you observe this small m, what I got as capital MA, I'm going to substitute here. Better I highlight. Otherwise, you may get some confusion what I'm saying. Yeah, thank you. Thank you. This highlighted box and the other highlighted box. Look at the two highlighted box. In place of F, I'm going to substitute capital M. That implies from the two boxes, F minus small f is capital MA is equals to small ma. That implies F is equals to what I supposed to write, MA plus MA. That implies F is equals to A in by M plus M. Yeah, good. That implies A is equals to F by M plus M, which is the common acceleration of both the blocks, capital M and small m. Okay, this is case 1, Nana. What I got here? Better I select another color. Yes, this is better. A is equals to F by M plus M. Keep it in mind, capital M, not F minus F, Manikanta. Bodudai. Am I right or Manikanta is right, Nana? I got this equation, whereas Manikanta got A is equals to F minus F by M plus M. Who is correct? By solving the two equations. Okay. Then, right. Good. Obviously, who said Nana? Sometimes I also do some mistakes. Why? Because I am also human like you. Right? Good. Okay. Thank you. Thank you. This is the common acceleration. Okay. And here my case is what I am saying. Unless and until the applied force, better I say, FMS is equals to say some 20 newtons between the two blocks. Unless and until I apply the 20 newtons, okay, is equals to 20 newtons, the block is at rest over with respect to capital M. But if I apply F greater than 20, what happens, Nana? Then small m slides separately or not? If the maximum value of static friction between the two is 20. This is what I'm saying. So you can say the common acceleration, the capital M is at rest with respect to capital M, unless and until here the applied force is equals to FMS. Okay. So this is case 2 what I am going to write. If the applied force is equal to limiting friction, then in that case, this equation, what I wrote here, this equation, what I wrote there, I have to write the applied force is equals to FMS. Correct, Anana? If F is equals to FMS, I can write it as mu S into N. Okay. Then in that case, I can write F is equals to mu S into N. Tell the normal reaction. Is it only small mg or only capital Mg or M plus M into G? Now I can understand that to what extent you understood the concept. Okay. Is it your answer, Manikanta? Bye, Ishan. I did not expect this kind of answer from you. Once again, think back, Ishan. Where is Abba Lakshmi Satvika? Where is the friction? On. Good boy. Now corrected. Yeah, Tanisha, correct. Yeah. This time Ishan is correct. Others, till now only 2 students put the right answer. Amog, correct. This time why Amog took this much time? Waste fellow. Badudai Manikanta changed the answer. Okay, now it is correct. Why all of you put the wrong answer first, Nana? Friction is acting here, na. There you are calculating the friction means above that surface, how much mass is there? That is the normal reaction. This model already I explained, no? One above the other. In Carom's game, 10 coins are placed. Normal reaction between 6th and 7th means above that, how many weights are there? We have to consider none. I already explained this model or not? Same type. I'm asking the friction here. So above that, how much mass is there? We have to see. Above that, small m is there. So here the normal reaction is small m into G, not capital M into G or m plus m into G. Okay. Yes. It is private. You can't chat with anyone. Whatever you chat, that comes to me only. Mr. Manikanta, take care. My, you want to chat with others in the meanwhile? Yes. Whatever you chat, that comes to me only. So take care next time. But it is coming to me also. Yes. Whatever he is chatting, I am also getting that answer. Right, come to here. So you can't chat personally. What with whom you chat? All the chats. Okay, right. So take care next time. So F is equals to mu s into n. N is here. I have to take mg. This is FMS, Nana. Okay, in this case. Whereas previous cases, friction is just nothing but the applied force. Okay, means in this case, in the two cases, I can say here applied force is less than FMS. If applied force is less than FMS, applied force is the frictional force. All of you know it. No need to explain. Okay, Nana? Right. Even here also they move combinedly. Why? Because applied force is FMS. And they move combinedly means common acceleration is equals to, no need to derive everything here. Straight away I write A is equals to F by M plus N. Okay. Do you have any doubt in these two equations what I wrote here, Nana? No. Right. Good. This is case 2. Oh, it's already 3:50 now. Right. Next case 3 tomorrow I will discuss, Nana. Okay. When the above block slides separately, what happens? Oh, sorry. That's it. Oh, I forgot giving the answer for that question. Okay, no problem. I will put the solution for that question, Nana, in the group. Once you check whether your answer is correct or wrong. Okay. Right. Bye, everyone. If you want the pages, you can take, Nana, quickly. This is page 1. Yeah. Thank you. This is page 2. Thank you, Nana. Thank you. This is page 3. Okay. Bye, Nana. Bye, everyone.